Welcome to the unit on circles. In this unit, we will be looking at the properties of circles and triangles. The objectives for this session are to apply the properties of circles and triangles to solving mathematical problems. A triangle has 3 points called vertices. A unique circle can be drawn through the vertices of any triangle called a circumcircle. The centre of the circle is called the circumcentre. It is the point where the perpendicular bisectors of each side intersect. For a right-angled triangle, the hypotenuse of the triangle is always the diameter of the circumcircle. This can be expressed as the following. If angle PRQ, as shown in the diagram, equals 90 degrees, then R lies on the circle with diameter PQ. And the angle in a semicircle is always a right angle. Let's now have a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. We will now solve example 1a first. Let a equal -4, 5, b equal 8, -1, and c equal 4, -9. And let these points lie on the circle as shown in the diagram. Show that AC is a diameter of the circle. So let's solve this. First, we're going to check that the triangle ABC is a right-angled triangle. Now, the length of one side, mod AB, all squared, is equal to 8 minus -4, all squared, plus -1 minus 5, all squared. This gives us 12 squared plus 6 squared, which is equal to 180. Now let's take a look at the length of the other two sides. So let's take a look at BC. Mod BC squared is equal to 4 minus 8 all squared plus -9 minus -1 all squared. This equals 4 squared plus 8 squared, which is equal to 80. And finally for CA, the length of CA squared is equal to -4 minus 4 all squared plus 5 minus -9 all squared, which is equal to 8 squared plus 14 squared, which is 260. So here's a summary of the results. Now 180 plus 80 is equal to 260. And therefore, mod AB squared plus mod BC squared equals mod CA squared, as shown. And therefore, triangle ABC is a right-angled triangle, and AC is the diameter of a circle. And now for example 1b. Find an equation of the circle. So let's solve this. The midpoint of AC is equal to x1 plus x2 over 2, which is -4 plus 4 over 2, comma, y1 plus y2 all over 2, which is 5 plus -9 all over 2. And tidying up, this gives us 0 minus 2. We also have that the diameter of the circle is root 260 from the solution to example 1a. So now we have the radius, which is half of this, and we have the centre of the circle, which is the midpoint of AC. So let's tidy up root 260 a little bit more to give 2 root 65. So the radius is root 65. And therefore an equation of the circle is x minus a all squared plus y minus b all squared equals r squared, which in our example is x minus 0 all squared plus y minus 2 all squared, which equals root 65 squared. And tidying up, this gives us x squared plus y plus 2 all squared equals 65 squared. So let's take a look at some more properties. Given any 3 points on the circumference of a circle, we can find its centre. And we can find its centre by finding the equations of the perpendicular bisectors of the 2 different chords, and then finding the coordinates of the point of intersection of the perpendicular bisectors. So let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. The points P, Q and R are as shown, and they lie on the circumference of a circle. The perpendicular bisector of PQ has equation y equals x over 2. This is illustrated in the diagram shown on your screen. Part A asks you to find the equation of the perpendicular bisector of PR. Part B asks you to work out the centre of the circle, and Part C find the equation of the circle. So let's solve this. We will solve example 2a first and find the equation of the perpendicular bisector of PR. Now the midpoint of PR is equal to 16 plus minus 7 all over 2, comma, 3 plus 6 all over 2. This tidies up to give 4.5, 4.5. The gradient of PR is equal to change in y over change in x, which is 6 minus 3 all over minus 7 minus 16, which is equal to minus 3 over 23. As shown. Since the gradient of PR is equal to minus 3 over 23, we have that the gradient of the line perpendicular to PR is equal to 23 over 3. Since the gradient of PR times the gradient of the line perpendicular to PR equals minus 1. And therefore the gradient of the line perpendicular to PR equals 23 over 3. So y minus y1 equals the gradient m times x minus x1 in our example implies that y minus 4.5 is equal to 23 over 3 times x minus 4.5 as shown. So if we tidy this up, we obtain y is equal to 23 over 3x minus 30. And this is the equation of the perpendicular bisector of PR. Now let's solve example 2b. We are required to work out the centre of the circle. So let's solve this. The equation of the perpendicular bisector to PQ, y equals x over 2, is given in the question. And the equation of the perpendicular bisector to PR is y equals 23 over 3x minus 30. This was found in part A. Now if we put these two equations equal to one another, we have that x over 2 equals 23 over 3x minus 30. As shown. And tidying up, or multiplying through by 6, gives us 43x equals 180. And finally, if we divide through by 43, we have that x is equal to 180 over 43. And so substituting this value, x equals 180 over 43, in the equation y equals x over 2, gives us that y is equal to 90 over 43, as shown. And therefore the centre of the circle is at 180 over 43, 90 over 43. Finally, we're required to find the equation of the circle. Let's find the distance between the circle centre, which is equal to AB, and is equal to 180 over 43, 90 over 43, and Q, which is equal to 12, 11, which is a point on the circle. We can do this by using Pythagoras, as shown. So this length is equal to 1 over 43 times root 259,585. So the equation of the circle is as shown. This brings us to the end of the session. If you have understood its contents, you should be able to apply the properties of circles and triangles to solving mathematical problems. Thank you very much for listening. If you would like to understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.